Hello everyone, my name is Bhiman. I am a computer science PhD student at the University of Pittsburgh, and today we are doing a deep dive on the infamous DeepSeek R1. DeepSeek R1 has become a hot news in the field of AI and even all over the world because it has surpassed OpenAI's O1, which is OpenAI's reasoning model on reasoning tasks like maths and coding. And today we will look how DeepSeek R1 was able to achieve this. DeepSeek R1 is first of its kind reasoning model which is able to show impressive reasoning abilities only through pure reinforcement learning. But there is a small caveat. Actually, there are two models. One is DeepSeek R1 Zero and DeepSeek R1. And DeepSeek R1 Zero is the one who is trained on pure reinforcement learning, but DeepSeek R1 use small supervised fine tuning. But you must be wondering what are all these terms. So let's look into how these models are trained. And before that, we will look into how conventional models are trained, and we will contrast it with how DeepSeek R1 and specifically DeepSeek R1 Zero was trained. So, to look into how conventional models are trained, we will look how LLaMA 3 is trained. So, in training of any large language model, there are two phases. One is pre-training and second is post-training. In pre-training, we teach language to the model, like English. This is done through next token prediction. For example, we give model a sentence like sun rises from, and it has to generate the most probable answer, which is east. After this, we come to post training, where we teach model to perform certain tasks from the language it has learned. So here we will say, for example, to generate an essay or a poem. However, this generation can vary in quality or it can generate some harmful content. So to check on high quality and no harmful content, we perform a third step which is known as alignment, and it is done through RLHF. And how RLHF is done? So, RLHF is reinforcement learning through human feedback. What does it mean? So, let's go step by step. So, we saw we got an supervised fine tune model in step 2. So, using that model, we generate multiple samples from the same input. Like for an essay, we will generate multiple essays. Now, we will hire a human, and the human will rate those essay generations on based on the quality. And then, based on those ratings, we will train a reward model such that the reward model can replicate the human rewards, so that in the training process we don't have to involve human every time. We use human only once, and we train a reward model with the human annotations, and in the training phase we will use this reward model every time. And then comes the final step, which is PPO, which is a reinforcement learning algorithm which fine tunes the supervised fine tune model, again using this reward model, such that model starts generating a high quality output. As you can see, using humans is very expensive. So to cut on this part, LLaMA 3 specifically uses a different reinforcement learning algorithm which is known as DPO, where it uses only the generation from the SFT model to and rate it in a different manner. We will go into more details about this part in later of our presentation. Additionally, to make our model more general purpose, we do instruction fine tuning, which is same as supervised fine tuning, but we add more tasks like translation, answering to your questions, code generation, and many other tasks which you can think of with ChatGPT do. Overall, these are the three crucial steps in conventional fine tuning of a large language model. Now we will go into details of each training step which are taken by LLaMA 3, which is our conventional model, and DeepSeek R1 0, and we will contrast what are the decisions they have made. So let's look into pre-training. For pre-training, first we require a model. So in LLaMA 3, a dense decoder-only transformer model is used, which is look like this, where you have multiple layers of decoder stacked on top of each other. Whereas in DeepSeek R1 0, a different model, which is mixture of expert, is used, and DeepSeek R1 0 uses DeepSeek V3 base as the model. In mixture of experts, you can think of it, there are multiple such models which are expert in different categories, and a router is being trained such that when you give a task about some category, only that expert is being invoked for that category. There are multiple flavors of mixture of experts as well, and DeepSeek V3 base uses this flavor of experts, which constitutes of two types of experts. One is shared and another is routed. What does it mean? It means that whenever you will give some query to the model, these experts, which are the shared ones, will always be used, and some among the routed experts will be used. What do they achieve with this? We measure the size of the model using parameters. So you will see that the LLaMA 3 has 405 billion parameters, whereas DeepSeek V3 base has 671 billion parameters. But since the architecture are different, in LLaMA 3 at the time of inference, all these 405 billion parameters will be used to predict, whereas in this mixture of expert, only 37 billion parameters will be used for the prediction. So this saves a lot of time at inference, because during inference we are only using 37 billion parameters instead of 405 billion parameters.
This was the difference in the overall architecture. You should be aware that transformers, specifically the decoder, are the building blocks of both of these models. But are they the same? Apparently, no. LLaMA 3 uses group query attention, whereas DeepSeek V3 base uses multi-head latent attention. Another difference comes in how the pre-training is performed. In LLaMA 3, as explained earlier, next token prediction is used. That is, it predicts single token at a time. Whereas in DeepSeek V3, multiple tokens are predicted at an instance. This was done to assist an advanced form of decoding known as speculative decoding. See, explaining all these terms would take a long time. The main takeaway is that each of these decisions was made to make the training and the inference process faster. However, answering fast doesn't imply the answer is always correct.
They call me the working calculator.
2 plus 2.
3.
What I mean is that making training and inference fast doesn't imply the model is able to reason. That means something else was responsible for the reasoning ability of DeepSeek, which we will look in the next part.